0.3. And odds ratio?
0.35.
What's the interpretation of these values?
People who are vaccinated are less, people who are in the place for group, negative association. People who are vaccinated are less likely to have the.
Or it means vaccine is a protective factor.
Yeah.
Or the risk of disease in vaccine group is less than the risk of disease in placebo group. Yes?
Yes.
Okay. What's the design of this study? Cohort. Vaccine and placebo.
Cross section.
No.
You mentioned all design except
Except the one.
randomized control trial.
Why we RCD?
Okay. Vaccine reduces its interpretation of this value. A vaccine reduces the risk of disease by, for example, 67% compared to placebo. It's the different type of interpretation. Or for example, risk of disease in vaccine group is 0.3 times the risk of disease in placebo, and etc. It means vaccine is a protective factor. In case control studies, we can calculate only odds ratio relative risk. In case control study, can we calculate relative risk?
Yes.
Yes.
Yes. In case control study, you can estimate incidence. You can estimate incidence? No.
Describe. For
Can you calculate incidence in case control studies?
no, because it's a control.
No? Sure?
Yes, we
There is
can.
incidence.
Why? Why we cannot? We cannot. But why? We cannot estimate the incidence. Why what? Why?
Because I think we are just studying the disease in the exposed environment.
Please repeat your answer.
Maybe we are just studying the disease in exposed environment.
Yes.
All of them have.
Yes. Because in incidence, in case control study, you cannot estimate the incidence because the starting point is selecting some disease and undiseased person. Yes, already have or not have a specific disease. And on the other hand, in case control study, you cannot you don't have a follow-up period. Yes, and you cannot diagnose new cases because already all people or all cases have the disease and control don't have a specific disease.
So in case control, we just take the given
Yes,
given circumstance and we
yes.
just
So in a case control study, the process typically in case control studies, the process typically follows these steps. At first, selection of groups like case and control. And who are the cases and controls? People who have a specific disease are cases, and people who don't have any specific disease are controls. After that, you should measure exposure past exposure of case and control. Yes? For example, you at first you select some people who have lung cancer and some people who don't have lung cancer. After that, you use some tools or checklists or questionnaire to measure the previous exposure of cases and control. For example, risk factor behavior, or for example, alcohol consumption, smoking, and etc. And after that, you compare the frequency of being smoking in case and control. Okay? So, 2 by 2 table in a case control study means what does it mean, A cell?
Disease.
Number of cases who were exposed to the risk factor. Yes? B, number of cases who weren't exposed to the risk factor. C, it's true. Number,
No.
it's not correct. Because number cell B means controls, number of controls who were exposed to the risk factor. Okay? A number of cases who were exposed to the risk factor. B, number of control or non-diseased individuals who were exposed to the risk factor. C,
Number of cases who were not
number of
exposed.
cases who were not exposed to the risk factor, and D, number of controls who were not exposed to the risk factor. Okay. And the starting point is selecting case and control. After that, you compare the frequency of exposure in case and control. And the only ratio-based indicator to assess an association between exposure and outcome in case control study is odds ratio. Please check this process. Odds in case A divided A plus C divided A minus A divided A raised. Okay? It means odds in case A divided by B and exposed in odds in an unexposed person means C divided by D. It's okay?
I don't think so.
What does it mean, odds?
Or just basically the number of
Probability
people
of
who have
something
disease happening.
divided by probability of not happening something. Yes? This process is clear. And the answer, odds in case, means A divided by B, and odds in unexposed
C
C divided by D. It means it doesn't matter your design is case control or cohort. When you have a standard 2 by 2 table, when you have a 2 by 2 table, it doesn't matter. Your design is case control or core. Odds ratio A, B, okay? It's clear? Because in case control, odds in case A and odds in odds in control C it's clear, it's a calculation. Okay. So the only indicator for assessing an association between exposure and outcome in case control study is odds ratio, and odds ratio is A divided by B. It means odds in case, and odds in control means C divided by D. And finally, A multiplied D divided by B multiplied C. It's clear. It means we are comparing the frequency of exposure between case and control to determine if the exposure is associated with the outcome or not. And the interpretation of odds ratio is same with the interpretation of odds ratio in cohort study. When odds ratio is higher than 1, what does it mean? Exposure is a risk factor. When odds ratio is less than 1, it means your factor or your exposure is protective. And when OR is equal 1, it means there is no association. This slide compares the calculation process of odds ratio in cohort study and case control study. The final result is the same, but the process is a kind of different. Please check it. Please write this slide on your page, on your paper, please. The process of calculation odds ratio in cohort studies and case control studies. Please calculate odds ratio or the best indicator or index for assessing the association between rule of diet and breast cancer. It's a kind of case control study. You are absent. Can you leave the class? Yes. And it doesn't matter. Yes. Okay. Answer this question. It's a case control study. Please calculate odds ratio.
So we don't have the exposure.
What?
We don't have the exposure.
No, please, first of all, please depict. After that, I gave you some information about the their exposure. Please write or depict a 2 by 2 table at first. Yes, Yes, I know. Because I want to share some different scenario for calculating odds ratio. Please repeat this 2 by 2 table. After that, I gave you some different scenarios to calculate odds ratio. What's the total number of cases and control?
Yes,
It's clear. In the first scenario, please calculate odds ratio with this information. The number of cases who are exposed is 15. And the number of control who are not exposed is 125. Please calculate odds ratio. Please, at first you should complete this table. What are you doing? Please turn off your phone.
I did not understand.
Yes,
the-
what turn off your phone? Thank you. Please calculate this question.
risk ratio and
Write your question on the page. Yes. What's the odds ratio? Multiply and divide. Number cell A is 50. B C 100. Please calculate odds ratio. Finish? Please calculate odds ratio for this scenario. Finish? In this scenario, what is your answer? 50 multiplied. Yes?
Yes.
And in this scenario,
What is this?
100 divided 60. Yes.
You're absent.
He
Okay.
gave us exposure for cases, and then he gave us exposure for control.
Please interpret this odds
I
ratio.
didn't see that one actually.
6. What does it mean?
Positive association.
What?
Positive.
Positive association. Those who are exposed are more likely to, what's it called?
Or it
To be
means
positive.
the odds of
Or the opposite.
exposure
In the case
in case
population
is 6 times of odds in control.
Control.
It's a positive association. It means there is an association between exposure and outcome. Please read this slide and give me a summary. It's very important. It's so important for you. Relative odds or odds ratio is a useful measure of association and in both case control and cohort study. Okay? But in cohort study, the primary measures is relative. On the other hand, in case control, the only ratio-based indicator is odds ratio. Because you cannot calculate or estimate relative risk and risk in case control studies. Okay? In case control study, relative risk cannot be calculated directly, so relative odds or odds ratio is used an estimate of relative risk when the risk of disease is low. Okay. So far we talked about different measures of association in epidemiology, like including relative risk, odds ratio.
Excuse, can you revisit the last page? Yes, I didn't get the point. I didn't get the point.
The point is, in case control study, you have one indicator to assess an association. It's odds ratio. But in cohort study, you have 3 ratio-based indicators, including relative risk, rate ratio, and odds ratio. And today, we talked about 2 measures, odds ratio and relative risk. All of them are ratio-based indicators. Okay? But another approach is difference approach or difference-based approach to calculate or to assess the association. The most important difference-based index is attributable risk and excess risk, or risk difference. Relative risk and odds ratio is an important measure of strength of association, as I said before, and is important tools to assess an association, and it's a major consideration in driving a causal. Causal means aliyat, yes? But sometimes we want to answer this question: how much of the disease that occurs can be attributed to a certain exposure? For answering this question, we can use risk difference measures. So sometimes the question is that how much of the disease or a specific disease that occurs can be attributed to a certain exposure. For example, how much of lung cancer can be attributed to being a smoker? It's because of being a smoker. For answering for answering this kind of question, you can calculate risk difference measures or risk difference based measure. Okay? So, for example, you want to answer this question, how much of the coronary heart disease risk experienced by a smoker can be attributed to smoking? For answering this question, you can use risk difference approach, and for example, we can calculate risk difference, attributable risk, percent attributable risk, and population attributable risk, and percent population attributable risk. All of them is important, but right now we are going to talk about attributable risk in exposed individual and percent attributable risk in exposed individual. And I sent you some practice about population attributable risk and the percent population attributable risk, and you should send me on email your answer. I think two practice. Okay, attributable risk. What is attributable risk? Attributable risk is the incidence of disease in the exposed population whose disease can be attributed to the exposure. And its formula is incidence in exposure group, exposed group, minus incidence in unexposed. And we cannot calculate attributable risk in case control study or in cross-sectional study. Attributable risk can be calculated in cohort and randomized control trial. Why? Because in other study designs, you cannot calculate or estimate incidence. And for calculating attributable risk, you should have incidence. Because you need risk. Can you calculate risk in case control study? No. Can you calculate or estimate incidence in prevalence study or cross-sectional study?
No.
But you can calculate incidence or risk in cohort and RCT. Why? Because in this kind of study designs, we follow people and we can diagnose new cases. So we can calculate incidence of a disease. Okay? Sure?
Yes.
So attributable risk means incidence in exposed group minus incidence in unexposed. Please write this example.
Oh.
I think I have some example here.
Same incidence of disease, risk diffusion, and counts the risk or chance of disease in exposed population. It can be linked
To the factor. Let's say there is a population.
to the exposure.
Yeah. Let's say there is a population who is not exposed to the disease. And they are not exposed to the factor that has been counted. Okay, someone who does not smoke develops lung cancer. So that's not linkable, right?
Yeah.
Because he didn't smoke and still got the lung cancer. So this means that there is a chance that lung
Please.
cancer totally does not depend on.
Yeah. That's
But now this is different.
they say how much can we link. It's used to link the occurrence of the topic.
Please answer this question based on this
This is
table.
with exposure.
Please calculate the risk of disease in exposed group, risk of disease in unexposed group, relative risk, odds ratio, and attributable risk, or risk difference. Please write your question, write your answer. One by one, I ask you, what is the risk of disease in exposed group? Please you. Yes. What is the risk of disease in exposed group? I haven't. I wait for your answer. I'm here.
So we have to calculate the odd ratio and like all the things that are in there. And
Yes. At first, risk of disease in exposed group. What is risk of?
Do you want to answer? Answer?
No, no. You don't know?
Risk is the same as the incidence.
No. What is risk of disease in exposed group? Yes. Risk of disease in exposed group. A for 1, risk of disease in exposed group. 84. Risk of disease in unexposed group. Please you. No. Please. Risk of disease in unexposed group. When you want to estimate or calculate the risk of a specific disease in exposed or unexposed group, please, you should limit your calculation into a row. Yes? In this scenario, you want to estimate the risk of disease in unexposed group. So, 87 divided by 5,000. And what is risk ratio? It's very easy.
Is the risk of
divide
Yes.
the risk of
just divide
exposure
both of them.
divided by
It's clear.
yes.
And odds ratio, it's very easy. A multiplied
D
B divided by
B divided
B multiplied C. Okay, now please calculate risk difference. It's very, very easy. It's very easy.
It's just
84 minus 87.
Yes.
Yeah, it's minus 3.
So it's minus 3?
Yeah. It appears.
No,
minus
risk difference or attributable risk. Yes? Risk in exposed group minus okay. So
subtract this. And then see.
87.
this is attributable risk or risk difference. Risk difference is better than attributable risk. It's very common to use both of them, but totally it doesn't matter which one of them you can use. But it would be better to use risk difference or attributable risk. Yes.
Mm-hmm. Yeah. 8 times D. Yeah. Yeah. This,
For example,
this minus this. Okay, yeah, that's also correct. And this is the same.
it's a cohort study or case control study.
Cohort study.
Why? Because we have incidents.
Yes.
It's very easy. In case control studies, you cannot calculate risk. Yes?
Yes.
And the objective of the study is to assess the association between high blood pressure and MI. Okay? It's a cohort study. It means at first you selected some people who have high blood pressure and some people who don't have high blood pressure. After follow them, 180 people developed MI, yes, in high blood pressure group, and in another group, 30 people developed the disease or MI. Right now, you can calculate risk difference or attributable risk. You should calculate risk in exposed group and risk in unexposed group. After that, you should subtract risk in unexposed from risk in exposed.
1.5.
Another important indicator or index or measure for assessing the association between two variables is attributable risk fraction or ARF. ARF means risk difference divided by incidence in exposed group. When we want to calculate attributable risk fraction, at first you should calculate risk difference. After that, your result should be divided by incidence in exposed group. right now we can calculate or we can solve some problem. I think it can be so helpful. For example, in this scenario, you want to estimate attributable risk fraction. At first, you should calculate risk difference. Yes? After that, your result should be divided by risk in exposure. Please solve this problem.
0.8.
0. No.
6.
Attributable risk fraction. Risk difference
Yes, 0.8.
divided by incidence in unexposed group. And usually we report attributable risk fraction as a percent. Yes? 83.3. What does it mean? What does it mean? 83.3.
Attribute fraction is more or higher.
What does it mean?
The disease and the proportion of the people who get the disease in the exposed group of people is this much, is 83.3%.
It means it's very easy.
The risk.
It means this 83 is answer of this question. How much of a specific disease can be attributed to a certain exposure? It means 83% of all MI cases in
Because of
exposed group is because of
high blood.
being exposure with, for example, high blood pressure, or is because of being high blood pressure, or because of hypertension.
Yes.
For example, how much of lung cancer can be attributed to a certain exposure like smoking? For example, after calculation, our result is 50%. It means 50% of the lung cancer
Can be attributed to
being a smoker. It's very good. And it's so practical and so useful in public health because politicians or policymakers, sometimes we can make some decision about some exposure or some intervention, and risk difference or difference approach is very so helpful because it can show us how much of a disease can be deleted or can be eliminated after, for example, after a specific intervention or after eliminating an exposure. It means if I delete or if I eliminate a smoking, we can decrease
the
the
risk of
incidence of
by 50%.
lung cancer 50%. It's very important. Please calculate attributable risk fraction for this example. How much of coronary heart disease risk experienced by a smoker can be attributed to a smoker based on this scenario? What?
49.1%.
Please calculate after that we will check.
question, I think the question is written wrong. You see what the question says, how much of CHD is experienced by smokers versus smokers? Because all of the who are smoking and have smoking are smoking.
It's 50%.
The question is how much of what
Just divide it, bro. And minus. And after that, divide it.
Just 0.02 minus 0.01 upon 0.02. Here it's equals to 0.02.
Okay. Finished?
Yeah.
Is it 84 by 171?
84. Please write your answer on the table, on the board, please. This is yours.
I don't know, I mean maybe.
The question is, how much of those who have coronary heart disease
It's because of
smoking.
So it should be then 84 by 171. Am I correct?
No.
Please write your answer.
Yeah, just
You should calculate attributable risk fraction. Yes?
yeah.
Because for answering this question, you should calculate attributable risk
the risk
fraction,
of, yeah.
not attributable risk. At first, you should calculate attributable risk. Please calculate attributable risk.
One. I didn't understand.
Risk difference.
The risk difference.
Risk difference.
Between those who.
Smoking and
What is the formula of attributable risk or risk difference?
It's those with the
risk of
Please write. 84 divided by
3,000.
3,000 minus
87
87 by 5,000.
by 5.
87 by 5,000. Over 5,000. Yeah. And then divide by?
it's
It's-
risk
yeah,
difference
it's-
or
it's
attributable risk.
Yeah.
But right now,
We want
we want to calculate attributable risk fraction. So
It
you
should
should,
be this times
you should-
100.
yes, divided, no, divided by risk in exposure.
84 divided by
84,
Multiply by 100.
3,000.
yes, multiplied by, for example, person.
The whole it has to be multiplied by 100.
No, hold on.
Yes,
To get the
fine.
37.
Please calculate with calculator.
0.0.
Do we get
0.01, I think.
37.
No, percent.
Yes.
Good.
Okay. Okay, thank you. Or there are
Yes.
another approach for calculating attributable risk fraction, and it's so easy. Please, yes, so easy.
Is in
It's
then
very
that
easy, to be honest. Please take a look at this formula. Another formula for calculating attributable risk fraction is here. Relative risk minus 1 divided by relative risk.
another one is very easy.
Here, I give you I gave you an example. Smoking and CHD. And based on this formula, attributable risk fraction is 50%. Right now, please calculate attributable risk fraction based on this formula.
Sir, do you mean that is for the unexposed over the exposed?
What?
The related risk minus 1. Do you mean to say that it is for unexposed?
Here,
Yeah.
yes, relative risk. Relative risk is relationship or association between exposure and outcome. Relative risk between smoking and CHD. It means risk of CHD in a smoker group divided by risk of disease in unexposed or non-smoker.
Then slow down.
The answer is same.
Oh my God.
The result is same?
Yes.
Yeah.
Please tell me your answer. Relative risk is
1.60.
You just told different way to calculate the attributable risk.
1.6.
relative risk.
There are two formulas. First is regards.
Yes?
Yeah.
2. Okay?
No, just get the relative risk and then.
Relative risk.
It's 1.6.
2. Relative risk minus 1 divided by relative risk. 2 minus okay? They are safe.
Excuse me, Professor. Are we going to get questions like we will be given the risk, the relative risk and the incidence, and then we'll have to calculate?
For exam,
Yeah.
yes, you should calculate relative risk, you should calculate, for example, please. Your friend has a good question. Please, again.
I
ask.
forgot my question, I think. Yeah, because I'm thinking.
This question is about your exam. For example, what kind of question I give you for exam? Exactly like this.
Not
You
more
should
complex.
calculate relative risk. You should calculate attributable risk, and you should know how to interpret this measure. For example, what does it mean attributable risk fraction? It means how much of a specific disease can be attributed to a specific exposure. For example, in this scenario, in this example, 50% of all CHD case in a smoker group is because of being a smoker. It means if you delete or if you eliminate a smoking in this scenario, you can decrease the rate of or the incidence of CHD by 50%.
Doctor, what about the number? The same, this is difficult. Like you need to calculate it?
No, you don't need to use a calculator. It's very easy like this.
Okay.
هو انت الكمبيوتر استخدم الحاسبة استخدم الحاسبة بالكمبيوتر
Risk ratio can be calculated in cohort, and
Case control?
please.
No, not in case.
Oh, because there is no risk.
Yeah.
Java.
Risk ratio can be calculated in cohort and odds. Odds ratio
Case.
can be calculated in all studies.
Also.
Cross-sectional, case control, cohort, odds. But the priority measure in cohort is relative risk. The primary measure of association in RCT is relative risk. But odds ratio is the primary measure of association in case control. Yes?
Yes.
Absolute or attributable risk can be calculated from cohort and RCT. Why? Because this kind of studies can provide us incidence or risk. And attributable risk fraction can be calculated
Also.
in cohort and RCT.
Okay.
Okay? Please answer this question.
I think so, but I know it is.
Okay, please answer this question. Which measures of association can be calculated?
Odds ratio.
Please calculate odds ratio.
What he wants? What he wants?
He wants the odds ratio.
Please,
It's one.
based on this table, at first, please calculate odds
Exposed in cases.
odds in cases.
Exposed. Divided by exposed. Unexposed.
What is odds in cases?
One. Is it? It's one.
Shoista, please answer this question.
You're gonna take 100 by 500?
No, please calculate odds in cases.
Yeah, that's what I'm telling you.
100?
by the 300, and then 100
Oh.
by 100.
No.
Odds, not odds ratio, odds in cases and odds in control.
Okay, so 100 by 200.
One.
100 by 100.
Yes?
Then that's 100
By
over 300. That's
And
the control.
100 over 300.
3.
That's 1, and that is
And what's
100.
odds ratio?
3.
It's 3.
Yeah, 300.
How many cases over 100?
Okay. Odds in case A divided by C, and odds in control B divided by D, and after that you can calculate odds ratio. Okay. Next session, I'm gonna review yesterday's quiz. Unfortunately, considerable part of you didn't answer questions, and it's so boring, I think.
Yeah.
Scary, I think. Yes. If you agree, we can have a break, I think until 11:30. After that, we can start next session, and we are going to talk, we are going to review previous quiz, I think, because it's so important to learn.